just introduce myself then, or
Yeah.
go from there, right? Okay, just give me the cue.
Okay, go ahead.
Hello, everyone. I'd like to welcome you to today's webinar. My name is Chris Lumpkin, and I'm a Senior Solutions Architect with CAS Severn. Today's topic that we're going to be going over for the next hour is BigFix, which is an endpoint management solution. So with that, I would like to first, if everybody should be able to see my screen, tell just a little bit about CAS. So CAS has been in business for over 39 years, and we have a facility that holds 31,000 square feet located in Laurel, Maryland. You know, we host the large meetings, we host seminars and training sessions, and we're heavy in engineering services. We also have within our facility a fully redundant data center where we host our clients. What I'm focusing on today, what I'm focusing on today, is the CAS Severn Security Services. CAS in whole has many other components. We deal with storage, we deal with a number of other solutions out there in the marketplace, virtualization, Windows, AIX, iSeries. Today I'm focusing on our security services, most importantly obviously the BigFix Solution, patch management. We do our own patch management hosting services, and we provide that in a fully hosted solution. We provide a SaaS solution, and we also provide an on-prem solution. We also are experts in the SIM marketplace, so we provide SIM solutions, identity and access management solutions, along with application and data security solutions. And we tie all those in together. So that's a short little synopsis about CAS. So getting into our main topic here, I want to pull up the Gartner's 2015 report that shows that IBM's BigFix is in the Magic Quadrant and the leader, and actually ahead in the visionary side of it as well. But it's a leader in the marketplace. So a little brief history of a BigFix, we'll go into it. How I'm going to break down this presentation today is really in two parts. I'm going to focus on the architecture of the product, and then I'm going to focus on the functionality of the product. And you're going to find it's very valuable because it's important, obviously, that the solution will meet your requirements, but it's also very important that the solution will be able to be integrated into your environment, be sustainable in your environment, and be able to scale in your environment. And that's really the architecture of the product itself. So that's how I'm going to break these two down. Architecture and functionality. So really, a question that always comes out is, why do all the other approaches, or many other approaches, fail? Let's be just blunt about that. Why do they not stand up? Why do we have problems with them? And really, I've broken it down into three categories: the architecture, the complexity, and the resources. Okay? The architecture, traditional solutions out there are slow, they're scan-based architectures. And really in the IT world, scanning, and the word scan is a four-letter word because scanning equates directly into lost performance on your endpoint. When you scan an endpoint, you're going to take a hit at some point in the performance of that. Right? Limited coverage. And limited coverage really we can equate to two things. One is the limited coverage of today's enterprise environments, which have multiple OSs. Typically, traditional solutions out there for endpoint management or patch management specifically only cover one OS, a Windows, or you'll have a separate solution for your Mac environment, a separate solution for your Unix and Linux environment. So it's very limited coverage for those products, and not cost-effective to scale, which leads right into that. If you have a solution that only does Windows and your corporation now brings on different OSs, you have to now start bringing in a different solution. Not very cost-effective because that different solution is a different point solution. You now have a different architecture most likely and a different rollout process. Right? That leads into the complexity. You know, these traditional solutions are heavy resource-intense agents because typically they're doing scans. So they get a directive from the server saying, I need information. They do a full scan, and then they push that information back to the server. Multiple products, multiple agents. back into kind of similar to the architecture. You have a Windows environment, you have a Windows solution. You bring in your Unix, Linux, you're bringing multiple products in to handle that one solution, the one requirement, which would be patching in this example. And then you also have multiple agents. So you have a solution that's for Windows, that's patching, you have an agent for there. Now you want to do, let's say, antivirus. That's a different solution, different agent. You know, you want to do some inventory, different solution, different agent. All right, so it continues to grow and build on your endpoint. And not internet friendly. This is actually really huge in the marketplace nowadays, and quite frankly, traditional solutions out there, once an endpoint goes off-prem, it goes dark, which means they don't have any insight into it. So your mobile workforce, your laptops out there, they're not getting patched, you're not seeing any kind of security posture, you don't know what state they're in. All right, when they come back on-prem, plug back in, they could be days to weeks behind on patching, on security updates, and then your network's at risk. So that's complexity. And resources, really, what does it take to manage these traditional endpoint solutions? Typically takes a fairly large workforce, we'll call it, from a server farm, depending on your environment size, to how many FTEs it takes to run that management solution. So it takes a lot of admin, it takes a lot of on the infrastructure, and there's a lot of work intensive when it comes to managing the actual patching solution. So what we are presenting today is BigFix, right? And BigFix actually started in 1997. So BigFix is a very mature solution out in the marketplace. In 2010, IBM started their due diligence to come up with an endpoint management solution that they wanted to utilize. They did their searching, and they came up, and one of obviously the vendors they were evaluating was BigFix, and they liked it to the point where they ended up purchasing the company. All right, so BigFix, and I'll get to this later in this presentation, is managing all of IBM's infrastructure. All right, every endpoint within IBM's workforce is managed through BigFix, and we'll show you. So they actually use the product themselves. Right. So the big difference in the marketplace with endpoint solutions that BigFix has introduced was they really flipped the solutions on its head. Traditional solutions were a dumb agent, smart servers. All right. Your server contained the policies and made the decisions and then told the agents what it wanted to do, which was typically just run a scan. So the agents were dumb agents, and they did not autonomously enforce any policies. Right? So they relied on polling and distributed database repositories as well. What does that mean? That when it came time to do patching, once a week typically, your endpoint was scanned, brought that information back into the console to the server made the decisions, put the policies together, and then started the patching process. What BigFix did from inception was they flipped the paradigm on its head and said, you know what, we are trying to manage our endpoints, so let's get more control of the endpoints. So they created a smart agent. So we'll call it the smart agent dumb server scenario here, where the server distributes policies to the endpoint agents. The agents store, enforce the policy, and they continuously manage and assess that endpoint. So the bulk of the processing is performed on the agents, which allows you to increase the scalability and decrease the cost without burdening the endpoint at all. Okay? So with that paradigm there, and this is going to be a thread that goes throughout this webinar, that smart agent is the brains of the operation. That allows BigFix to do what it can do, which is what we're going to get into. I'm going to show you now. All right. There's basically we'll call 4 elements to the BigFix solution. Right. The single intelligent agent, right? A continuously self-assessment of that endpoint, continuously policy enforcement, and here's the big thing: it's minimal system impact, less than 2% of the CPU, and less than 10 megs of RAM. All right. So we'll make a statement, and I'll thread this throughout the webinar. BigFix solution will not affect your performance on your endpoints or your entire infrastructure, and you'll see how that works out. You have the ability right off the bat with the with this agent to have minimal to really zero impact on your endpoint with the percentage of CPU it takes. And then the architecture, which we're going to go into, is going to be self-aware of your bandwidth within your network to allow you to do patching to transfer payloads from source to source without affecting your performance. Right? So I will continue focusing on a single intelligent agent because that's really the brains of the operation. What we have because of this architecture is a single server and console. It's highly secure, highly available. All right? Aggregates data, analyzes, and reports. All right? This infrastructure allows you to manage up to 250,000 endpoints per server. So keep in mind as we continue to talk about this endpoint solution, which we're focused on the patch management portion of it, all right, your scalability is immense. One server, could be virtual, could be physical, will manage up to 250,000 endpoints. So your scalability is already built into the product. So whether your infrastructure has 10 endpoints or 10,000 endpoints or 100,000 endpoints, one server will manage it. All right. Virtual infrastructure. All right. So BigFix can designate agents out there as relays or discovery points within minutes, and we'll get into what that actually means. So it provides built-in redundancy, and it will leverage your existing system and infrastructure for the scalability of the product itself, and that will become more clear as I discuss this going further. Then we have the bottom left here on the screen, flexible policy language. We call them fixlets. All right, fixlets are simply little programs. All right, very minute little programs, 1 to 2K. All right, and IBM provides these fixlets for you within the solution, so that there are thousands of out-of-the-box policies. All right, the best analogy I'll give you and how this works is every patch that Microsoft creates, IBM takes those patches and creates a fixlet. Right, and a fixlet, like I said, the little program, it's written in the proprietary language called Relevance, very easy to understand. IBM provides this content for you and automatically deploys it into your servers for you. All right, so it's a very highly powerful language. These fixlets are part of the secret sauce within this, the product itself, which we'll get into and become more apparent as we discuss this going further. Okay, so those are kind of really the four main elements of the BigFix solution. And this is considered a next generation solution. Why? Because it's real time. All right, because of that active intelligent agent, which is continually assessing its endpoint, reporting back in, you have the ability to see real time what is going on with your infrastructure. Okay, so let's kind of jump to an infrastructure. So this is what we'll call a typical enterprise infrastructure out there. Yours may look very similar to this. It might be a little bigger, it might be smaller. But what you're going to notice here in this infrastructure is that most enterprise networks are highly distributed. Right? Users are connecting to the headquarters site from across the internet, while on the road, and from remote offices, right? Which makes security and system management extremely challenging. Additionally, most enterprise networks have bandwidth constraints, whether it's over wireless, shared MPLS, satellites, etc., which makes pushing fat software packages or patch deployments and security patches over latency-prone links a huge burden on the organization. Moreover, many of these devices are intermittently connected, right? Particularly those roaming laptops, which makes validating and updating their configurations virtually impossible. Finally, most enterprises have many different types of servers, desktops, laptops, handheld devices, making cross-platform support a must for any security and systems management solution. Okay? So, unlike alternative solutions, BigFix was purpose-built to work efficiently within these types of environments. As you can see from the diagram, BigFix agents, and we'll jump here and advance the slide here. As you can see from the diagram, the BigFix agents can be deployed on all types of devices, whether you're running Windows, Windows Mobile, different flavors of Unix, Linux, AIX, Macs, it deploys to them all. Right? The BigFix agent is the brains of a unified messaging platform, and it continually assesses the state of that endpoint against policies, whether connected to the network or not. As soon as it notices that an endpoint is out of compliance with a policy or a checklist, it informs the BigFix server and execute a configured remediation strategy that was in place, and it immediately notifies the BigFix server of the task status. So when you are pushing a patch out or doing patch deployments, you can literally watch and see the deployment. You can see the caching the payload. You can see it downloading it. You can see the running of the payload, and you can see the completion status of that. So what does the BigFix server do? Right? Well, the BigFix server manages the policy content. Right? It delivers messages called BigFix fixlets. Right? And it updates continuously via the BigFix content delivery cloud-based service. So in every BigFix installation here, you can see that there is over here the BigFix content delivery. This is IBM's cloud infrastructure. So every BigFix server, when deployed, will communicate back to the server securely, and this is where the fixlets come down. So in my example of Patch Tuesday comes out, Microsoft releases the patches. BigFix takes the patches and creates the fixlets. Once the fixlets have been created and tested, these fixlets automatically come down into the server. Right? Once the BigFix server starts seeing new content come down, BigFix server sends out a UDP request to all of its endpoints saying, I have some new content. Okay? At that point, the endpoint checks, looks at the fixlet, runs it, takes a nanosecond to run it, and basically says whether content is applicable to it or not applicable to it. Okay? So one BigFix server can support more than 250,000 endpoints, as I stated before. So this enables the customer to make the most of their security systems and the investment they've made into it. So whatever specific BigFix solution the customer uses, whether it's the endpoint protection, systems lifecycle, security configuration, vulnerability management, patch management, which we're talking about today, right? It's all delivered via a single management console view. Additionally, new services can be provisioned and delivered via the BigFix Content Delivery Cloud with no additional hardware or software. What does that mean? Your initial interest, let's say, is patch management. Well, once the BigFix server is installed and the solution is rolled out, if you want to move to a lifecycle, which is a more robust, where you can do software deployments, where you can do OS deployments, remote control, your infrastructure does not change. You simply click on the software, and it's basically like a software subscription, and you add the abilities, the fixlets that you subscribe to now automatically come down. They go out to the endpoints assess them, whether they're applicable or not. So there's zero added infrastructure going forward. All right. As you bring on new offices, new remote offices, you simply deploy the agents out, they check in, and the BigFix server will then allow you to manage them. So deployment is straightforward. It's typically completed within hours, if not, a day or two. Agents, like I said, can automatically be installed within minutes without disrupting end users. Additionally, most customers deploy BigFix relays to help manage distributed devices and policy content. And as you can see in the diagram, an existing workstation can be leveraged for this purpose. So what does that mean? Well, again, in this diagram, every device, every OS device that will be managed will have the agent on there. So when the agents are deployed out, you're managing those devices. In this example here of a remote office, you probably have a domain controller there, a backup domain controller that's being managed as well. We can apply what's called a relay service. So we install this little program, and it's just a relay service. And here's an example of one right here. So what that relay does is that relay then talks back to the BigFix server, which means that all the devices in this local office here don't talk directly to the BigFix server over the WAN links. They talk to the relay. The relay then communicates over the WAN links to the BigFix server, right? So that allows the ability to scale out. It doesn't require any additional infrastructure, as stated. This relay is an existing domain controller or a backup domain controller or a backup server, or quite honestly, if it's a small office, it could be somebody's desktop. Relay servers can be installed on any OS. Okay, so that allows you to scale it out. And think of it as a parent-child relationship. The BigFix server is a parent. The relay is a child, all right, and then the relay's childs are the endpoints as well. Okay. So if you remember, I'm going to jump back into my earlier introduction of BigFix. So one of the main reasons that a lot of the traditional endpoint management solutions fail, it's not internet friendly. And in today's market, everybody's out on the internet. The new edge of networks is really the internet. It's your endpoint itself. So that laptop that's sitting right on your desk that you're utilizing, all right, that intelligent agent knows where this relay is and is communicating to the relay. When you pack up for the day and you go home, right, and you pop open a laptop and fire it up, that active intelligent agent knows that it cannot get to its relay because it's a private IP address, or DNS. So what it does is jumps to its what we call the internet relay, the DNS relay that you put out in your DMZ. All right, so in my example, and in this diagram here, here's your DMZ that you're managing it. And within your DMZ, you probably have a web server, an FTP server, a device that has a public IP address on it. All right. With that public IP address, BigFix will use that public IP address, and it'll automatically then, once the relay service is installed, be forward-facing. So that device in your DMZ with a port 52311, and I'll get into exactly what that is, will communicate to any device in the internet. So the laptop is at home. Once you have a Wi-Fi connection, that intelligent agent will then jump to the DMZ relay, and it'll connect in. So it could be at the airport here. You pop up in your laptop. The agent realizes it can't get back to its original relay. It'll go to a secondary DMZ relay, comes into the internet, and now it's communicating with the BigFix server, all in real time. So really, any mobile device, any laptop on your infrastructure, once it has an internet IP address and it's on the web, it will communicate back into BigFix, and BigFix can manage it as if it's on-prem. All right. So that's huge in this next generation endpoint management, because it gives you that flexibility and ability to see in real time your devices no matter where they are. So in patching cycles, you don't have to worry about laptops that are off-prem, and when they come on, they're going to get hit with a load of patches to be installed. They could be on the beach in Tahiti. As long as they have connection to the internet, they're being managed and they're being patched. For the cases where people shut down and turn off the laptops or their desktops, there's no way around that. Once they come back online, they will then receive whatever payload was sitting there for them and be patched. But the operator will know that that box was not online. Within the console, they'll see that it's not been communicating, and they can investigate whether the person's on vacation or there's an issue with the actual device itself. Okay, so the architecture is critical here, and as I've been laying this out. So let's add in the security of the architecture. Okay, when BigFix is installed, right, it's installed and utilizes just one port. By default, it's port 52311. So the BigFix server and all the agents and the relays communicate on a single port, 52311. Public keys are installed, so you have a public and private key installed on the BigFix server. So all the communication is secure between the server and the agents, right? That you can then encrypt it as well, okay? So you have secure communications from the agents to the BigFix server. So back into that laptop that's on the beach in Tahiti, all right, it has connectivity back into the BigFix server over port 52311, and it's secure communications. So number one, your security people that run your firewalls only have to open up one port. Very simple. And you know that any traffic through that port is going to the BigFix server. So you can manage that as well. All right. The other part of that is, if you look at different scenarios that this can provide, we have a number of clients that have a large mobile workforce, and they VPN into their infrastructure. one of the biggest challenges that the help desk has is when that VPN client gets corrupt. Because once the client is corrupt, then the end user needs to physically bring in that laptop to the help desk so they can reinstall the VPN client. So what BigFix can provide is, within the architectures, they have their own self-service portal, it's called. So what it is if your VPN client gets corrupt, and this is what we helped with our client do before, is we created a fixlet that was literally the VPN install, and it was a Cisco VPN client. So when the end user realized that saw that their VPN client blew up, one of them didn't work, instead of calling the help desk, all they did was open the self-service portal, which is that intelligent agent, and there sitting there was an executable, well, it wasn't what we call a fixlet, that they executed, that then downloaded the content, which was the VPN client, to their endpoint and reinstalled it. So it allowed the end user to remediate an issue they had. And even if the end user called into the help desk could then walk them through quite quickly what they needed to do, and not take up a lot of time, so it becomes a lot more efficient to be able to do that. So as you can see, this infrastructure and the deployment of BigFix, the architecture, really lends itself to a next generation, lightweight, very scalable, real-time environment. All right? We have done many deployments of the BigFix infrastructure, and typically within an hour to 2 hours, the server is up and running, communicating with the cloud, IBM's cloud, bringing down the fixlets, agents have been deployed, and you have an operational environment literally within hours. All right? Because of the real-time ability of the agents, within that first day, we would typically have patching reports that can show the actual status of the endpoint in the patching posture. Okay? So I've laid out the architecture of the environment. We've hit on the fact that this architecture will support multiple OSs, actually 90+ OSs, from Windows, AIX, Linux, Unix, Macs. It'll handle them within this infrastructure. We're talking about patches today. We're going to get deeper into the patching ability, but this architecture is critical, and it's going to be laced in throughout the conversation because of the intelligent agent. Another supporting feature within the patch management of this product is third-party applications. All right? So BigFix will support Adobe and other third-party apps that you'll see in here and some of my screenshots as I go further. Okay. So as we've built out the screen, managing remote offices, whether it's a T1 or a satellite connection, with the ability that BigFix has built in and of the relay architecture scalability, it knows what bandwidth you have out to devices, to your remote offices. Okay, so with that said, when you have a patch deployment coming out and you have a payload, and in this example, let's say it's a 200 meg payload worth of patches, all right, and you're going to be sending it out to one of your remote offices that's just connected with a 56K line, all right? So you don't have a lot of bandwidth. Well, what you can do in that regard is twofold. One, BigFix has the ability to cache the payload onto its server and then trickle down the payload to the relay in the remote office. So in this example, we'll use the 56K remote office here. So this utilization on this line is going to max out really quickly. So BigFix can sit there and it'll monitor this line, and it'll notice that, all right, you're running at, say, 40% saturation on that line. And then you can tell the relay, which is communicating back to the BigFix server, so I want you to use 10% of the available bandwidth. So 60% is available. I want you to use 10% of the 60%. All right, and then it'll start trickling that down. So you could do a patch deployment, send it out on Wednesday, and actually have it execute on a Saturday. So it has Wednesday, Thursday, Friday, and then Saturday morning for that payload to get there. Once the payload is sitting on the relay here, cached here, it will then deploy out locally to its devices in real time. Okay, so it's just one mechanism. Another mechanism that we can utilize that BigFix has the intelligence for is many of these offices, and most likely this remote office, will have grown over the years and have connected a dedicated internet connection. So most likely when we see these kind of scenarios, this infrastructure, this dedicated internet connection is probably a cable DSL, which is probably 5, 10, maybe even 25 megs of bandwidth, which far is far much more bandwidth than 56K. So BigFix has the intelligence to take advantage of this. So the console and operator can sit there and say to this relay in that remote office that, you know, we're going to do patching on Saturday morning, and kick off the process and tell the relay to download the payload. So the relay will then go out to the respective source, download the payload, cache it on the server, and then when the time comes up to patch it, patch the endpoints 8 o'clock Saturday morning, it then deploys out the patches. All right. So the actual payload never went over the WAN link. It came down through the internet on that remote office. So as you can see, there's a lot of abilities here that this has to utilize the existing infrastructure, right, and be able to provide successful patching, right. Last one that popped up there is identify unmanaged assets. So this is very simple to do, and this is another ability of BigFix where in a remote office, it can designate one of the agents or endpoints in our remote office to do an mmap scan. Typical protocol out there. The only time you'll actually hear me use the word scan within the BigFix realm, but it can tell that endpoint to scan that subnet and give the results back. Because it could designate an endpoint, and the scanning isn't going from the headquarters, so the BigFix server all out throughout the net. It's going and originating right from that local subnet. So it's much more efficient, much less intrusive. And what it does is this brings back all the assets that have an IP address assigned to it. Now BigFix only manages assets with an OS. You know, that we have mentioned, Windows, Microsoft, Windows, and Unix, Linux. It'll identify your firewalls, your routers and switches, and do a best guess of what the operating system is or what the make and model. But it does not manage those. But what you can have with BigFix, with its intelligent agents, is you can say, you know, I want, you know, Saturday morning or 2 a.m. on Monday morning, I want to do a scan of my local subnet from that one endpoint, and I'll be able to see any new devices that come in. And if it has an OS that I manage, you can deploy the agent to that OS. All right. So it gives you the ability to manage to a degree, all the devices that have IP addresses. All right. So what we have gone through now is the architecture. We laid that out at a fairly high level. There's a lot more detail we could give, but we can, you know, if there's an interest, obviously we'll circle around with you guys and give you more information. Now we want to segue into the functionality. You know, so with the BigFix solution, what functionality does it provide? And majority of all my examples have been towards the patch management, right? So in the BigFix endpoint management, you know, we've talked about patch, and that provides you, there's an executive dashboard. We talked about OS patching, third-party apps patching, and offline patching. But with that same architecture, and as I mentioned before, just subscribing to different domains, so to speak, this is what BigFix full functionality can provide you on that same existing infrastructure. All right, and as you can see, it gives you in what we call 5 domains, and they are lifecycle management, and that really is the lifecycle of your endpoint. So as you can see, it does patch management, asset discovery, software distribution, advanced patching, remote control, OS deployment. It does power management, and then sequential task automation. All right. Sequential task automation is actually very popular, especially in the VM world, so that you can actually, BigFix will tie into your vCenter, and you can automate a number of tasks within your virtual environment. A good example for that would be you have a exchange, a 3-node exchange cluster. All right. Well, you can create a plan within BigFix that it will go pull out one of the nodes, patch it, reboot it, put it back into the cluster, go to node 2. And every step within there will be sequential in the sense that it has to be a successful completion. It goes on to the next one. So you put this plan together, and we have actually seen infrastructures, companies that a typical 3-node cluster for Exchange will take as an end user I'm an IT admin, around a little over 4 hours, 4.5 hours to patch. By putting an automation plan together, we have been able to automate that and cut it down to a little over an hour time for patching it. But the most important thing to remember about that is that's completely automated, meaning there's no fat fingering of an issue in there. You don't have to have really a senior level guy who understands how to pull out the nodes and cluster of a cluster, do the patching, reboot it, and put it back in. And nobody's going to lunch or being distracted by other fires that come to light. So what you can do is you can use the value of the product. You can have your senior admin put the plan together, but then you could have somebody who literally at a help desk level be able to patch your Exchange cluster by just kicking off the plan. All right. The inventory, very popular. This does in-depth analysis quickly. Remember, it's an agent that has the brains that knows everything that's on your endpoint. And it knows that through fixlets. It asks simple questions. So it brings back all the hardware and software inventory that you have. Can actually do software usage reporting. Does catalog correlation. All right. So what inventory really can provide you, besides the fact we've all gone through the edits, or I should say the audits, where how many Adobe Acrobats do I have sitting out there in my environment? Well, I've purchased 100 licenses, so now I want IT to figure out and run a report. And that takes, could take some manpower to put that report together. Here you have that information at the tips of your fingers within the console. If you want a quick report, show me all the Adobe Acrobat, it comes up, there you go. You can actually put in your ELA agreements or your per seat license agreements into the inventory. So it can track how many you have, and it can let you and alert you that, hey, you've now gone over. You had 100 Adobes, you now have 101. It'll automatically let you know that and can process that and alert you. So inventory is great for managing your software licensing. We have many clients that brought in the inventory with their Microsoft ELA agreements because they deployed Microsoft Professional, Office Professional out there. With this, it tracks your usage, so it actually sees who's using it. So then what you can do when you're shoring up your licensing is simply say, you know what, I don't need to deploy the Professional out. I've got 30% of my workforce that have never opened access or PowerPoint or project. So I am going to then cut my licensing back and just go to standard for X amount of users. And that can save, depending on your industry or your size of your company, hundreds of thousands of dollars. All right. We discussed patch, and we're going to talk more about patch. Provided patch is kind of a baseline with the product. Patch is included in lifecycle. It's included in compliance as well. All right. What is compliance? Compliance is the security side of this. Security configurations, your vulnerability assessment side. It has thousands of out-of-the-box policies from DISA, STIG, CIS, PCI, HIPAA, that you can put your policy profile together, deploy that policy out to the endpoints, and the endpoints will real-time monitor their compliance. When they fall out of compliance, it'll be reported back in real time, and you can see your compliance of your endpoints. Obviously, a very popular product, runs on the same infrastructure, and gives you real-time insight into your security vulnerabilities when it comes to your policies there. And the last is protection. This is the ability to do the virus protection, built-in firewalls, data loss prevention, and device control. Again, all in the same infrastructure. Okay, so that's the suite of products that BigFix provides in total. All right, so let's continue with the patch management side of this. All right, so BigFix patch dashboard. So if you can see these numbers, great. I've blown up pieces on here to make sure you can definitely see them. But this is this is the console view of BigFix. All right, and to give you a quick navigation of this product, we'll start with the lower left here. Right, so down here, these are the domains that you subscribe to. If you just bought patch, you would just have this patch domain here. As you can see, there's security configuration, server automation, lifecycle, endpoint protection. Okay. BigFix management, this is where you actually manage your environment, and then all content. When you select patch management, the navigation goes clockwise. So when you select patch management, then upper left here is the patch management domain. It opens up and gives you the details about this. right? So right here, the patch overview dashboard, you can see at a glance that this one shows you critical patches needed. So within my environment, and this is actually a live demonstration environment that I have that this is pulled from, there are 809 patches available that are required, that are needed. All right, 62 of them are critical. All right, and it gives you the averages patch and average of critical relevant patches per machine. I have 42 endpoints that are subscribed to this, and my last update was the 15th, and this would be today's date if this was actually on the console, but this is just a screenshot. So it gives you information, overview of critical patches, and then you can go around the window and shows you the relevant criticals and that kind of stuff. So at a glance, you can see at a pretty high level what your environment has and needs. All right. So if we jump and I blow up the patch management side, you can see some of the navigations of how you can drill down. All right. OS vendors. So this just goes back to what I was stating, what it can support. All right. In my environment, I've turned on CentOS. There's one patch available in CentOS. IBM AIX is turned on. I have 0 patches available that are applicable to my environment. Microsoft Windows, I have 875. My Red Hat, 783. As you can see, VMware, 12. So these are the OSs that I have enabled within my environment. All right, and it's real time. These numbers change real time as patches become available and as patches are applied. All right. We go over to application vendors. These are the vendors that are automatically supported through BigFix, which means the fixlets are automatically created and come down to you, and you can apply them. Some of the big ones obviously are Adobe. They're huge for patches. Supports Apple, supports Google, obviously Microsoft, Mozilla, Oracle, which is Java. This is huge, and so on and so forth, and you can see. And then I jumped over to patch families. So BigFix gives you the ability to break down the content really in any fashion and flavor you want to. Here it's doing patch families. So my Exchange environment, all right, Linux, Office, SQL Server, different windows I can drill down into, and I can see, what patches are available within my infrastructure. All right. So as we move on here, what I have put up here is again a snapshot of my console, which we saw earlier, and you can see again upper left here the patch management. I can drill down when I pick new content. I can drill down by source severity, by site, by category. I've selected source. All right. There's Adobe showing up. I wanted Microsoft and I wanted my criticals. So as you can see, I've got 5 critical patches that are applicable to my environment. All right. If we go over, again, you can see how I highlighted critical here. New content pops up right here of the criticals. Okay. So here are the 5 criticals that that show here, and it shows you the patch, the ID, the patch, the size of it, the site, which is patches for Windows, and it shows the applicability. All right. So right now, obviously, 42 devices in my infrastructure. 17 of those devices, this patch right here, the first one is applicable to. Okay, gives you the source ID and the source release date as well. You can see I had this first patch highlighted. So again, the navigation on the console goes clockwise. So here's that fixlet in detail. All right, so this is the fixlet right here, and this is the description. So what this is IBM has taken this fixlet, taken this patch from Microsoft, and they've turned it into a fixlet, as I stated before. And they put in their description, right? So if you look up this actual patch, you'll find this is the exact information that Microsoft provides right here, what it fixes for. It gives you some notes about it and the size of the actual payload. All right. Details. We'll get to this. Details is the actual fixlet, the actual relevance language. Applicable computers. All right. In my environment, there are 17 that this patch is applicable to. And then we have action history. What is that? If any action was ever taken, meaning if I ever applied this patch, it would then audit that and tell me that there was a history there, and I can actually follow who it was deployed to. Okay. So if I want to patch this guy right now, I would simply either click the Take Action button, or I'd come down here to Actions and click Click here, which is the same thing. The second one is click here to see a knowledge base article for this update. So this allows you to go right to the Microsoft site or the respective patch and learn what it actually does. Okay. So this is the console. So let's, you hear a lot about fixlets. I want to make sure you do kind of understand the power behind the fixlet and what it provides and how it keeps this, it's really the glue to the BigFix. All right. So I pulled up an actual fixlet. All right. So as you can see, I've kind of zoomed in, but here is the detail tab of that fixlet we were looking at. And what is a fixlet? Like I said, it's a simple little program written in a language called Relevance. All right, and it's simply looking for conditions. So when Microsoft creates a patch, to be applicable to an endpoint, that endpoint has to meet certain conditions. It has to be a certain OS, right? Has to have certain things installed or not installed. All right, register keys, turn on, turn off, that kind of stuff. So BigFix has replicated and mirrored that in the relevance. So as you can see in this example, there are 5 relevance statements within this fixlet. For this fixlet, and we'll consider this patch, for this patch to be applicable, all 5 have to be true. So when that endpoint reads this fixlet and executes this program, relevance statement number 1, if this is false, it's done. It stops it. It doesn't go any further. It's false. It doesn't need to know anymore. It's not applicable. All right. If it's true, it goes to the second relevance, and so on and so forth. So if all 5 are true, this is applicable, and then it tells the console, it goes back to the server saying, yeah, this patch is applicable to me, and then applicable computers, it would register in. So that's how real-time this is. As soon as this fixlet becomes available, it executes it within nanoseconds, reports back it's applicable to me. Okay. Now, the action side of it. If you want to deploy this fixlet, all right, here within the second part of the fixlet is the action, what it does. And I haven't touched on this yet, but now we're going to, all right? The action is the actual download of the payload. So as you can see here, this action here is downloading from Microsoft. If you were to cut and paste this link into your browser, it would take you right to this patch and download it for you. So that has some real significance. And what the significance is as my whole conversation with BigFix, I've never talked about a repository for patching because there really is no repository that you have to manage. BigFix, when you take this action, BigFix will download this content onto the server or onto the relay, as I stated before, and it'll cache it there. All right. Now, by default, it's a 2 gig cache, and what it does is takes 2 gigs in your hard drive, where it caches it. And you can expand that to 100 gigs if you wish. But it's self-managed. It's first in, first out. So as the patch comes out and it's cached, it sits there. Next payload comes in and cached, cached. All right. So you never have to manage your payload. It'll manage itself. So if you execute this patch and it runs, it'll stay in the cache until it gets bumped out. All right. So 6 months down the road, if this patch ever became applicable again, it would just download it again and cache it. If it was already cached, it would just deploy and run it. All right. So it's very efficient. There's no need to deal with a repository and have to worry about a database with gigs of space that you have to clean up. Okay. So that's really a fixlet. Now, here's something I want to just kind of stretch your mind with when you think about this. You see this relevance language here, all right? And IBM is creating these fixlets for you. Now, there's also a wizard, a fixlet wizard that can help you create fixlets yourself. But there's also a fairly simple scripting language here. And what that means is you can create fixlets to ask any question of any device out there. So when you think of the power behind that, if I want to know how much disk space, I can write a fixlet for that, and actually that fixlet's already included in your life cycle. But I give you an analogy of how we've seen this product and how we utilized it to not only manage your endpoints in this scenario, do patch management, but to actually do troubleshooting. We had a client that had purchased 100 Dell laptops with SSD drives in them. And they deployed them all throughout their infrastructure. And what started happening was some of those laptops, the hard drives were blowing up. And after working with Dell, they found out that it was, there's two firmware versions on those SSD drives. We'll call it A and B. B was the updated one. If it had A, there was a bug in there, and it was causing those hard drives to blow up. So once they worked with Dell and identified what the issue was, well, now they're going back into their traditional IT project sense. All right, we got to find out who we deployed the laptops to. Then we have to find out if they have the firmware A or firmware B. All right, and then we need to remediate. If they have A, we need to upgrade it to B, and if they're B, they're fine. We were on site that day just doing some other health checks within the BigFix. When this was brought to our attention, we have to be in the conference room when they came in discussing the project. And what we showed them what they could do with the BigFix, since they've already had it installed, was we went in and wrote a quick little report to say, show me all the Dell laptops that have this specific SSD drive. And within minutes, that report returned, and we saw all 100 devices within their infrastructure, and they were all communicating. So at that point, we knew all the devices. We could then see exactly which ones had the firmware, A or B, and that firmware was actually a software upgrade firmware. So we downloaded the firmware, we were able to execute it, we packaged it up, and we deployed it to all of the endpoints that had the A. They received it, they rebooted, they came up, and they're resolved. So within a half an hour, we took what a typical IT project would have probably taken weeks to maybe a month to track that all down, do that, to literally a half an hour. So the power of this tool is immense. And that's why when you look at BigFix in the patch management scenario, you can understand how the patches work. Well, when you expand the breadth of the product, software deployment, or virus protection, remote control, now all these different abilities that it provides is all on the back of the fixlets and the active agents and its ability to work in real time. Okay, so in a typical deployment of BigFix, we do many proof of concepts, POCs. We'll come in within an hour. We'll have the server up and running, deploy agents to the specific pool that they want to test with, and they'll be reporting in. We'll be able to go into, there's a web interface that is for web reports. So it's a report engine, and it works right off of the main BigFix database that is in real time as well. So what we can provide is a report. So this is one of the reports that literally within an hour of installing the product and targeting their endpoints, we can show you what level of compliance they are within their patching. So this report is pretty simple. In total, they're 68.48% compliant. All right, they have 315 outstanding patches, installed, and 145 outstanding. Due to obviously the size of their environment, it's going to pick the 15 most vulnerable computers and list them out here. And what you can see, underneath is it's going to show you the actual computers, their operating system, and the applicable fixlets, which in this sense are actually patches. So there's 20 patches that are available for this, are applicable. All 20 are installed. Zero outstanding, it's 100% compliant, and it goes down from there. So this is a report that within minutes we can provide, or that you have your ability to have your hands on to see where you are with your patching. All right. So it's very powerful in that regard. Okay. So let's jump to some bullet points. I want to make sure that these kind of messages get out. All right. So IBM's BigFix patch providers, it's an automated, simplified patching process that is administered from a single console. Right? It provides real-time visibility and enforcement to deploy and manage patches to all endpoints on and off the corporate network. So clients have reported seeing more than a 98% first pass success rate. All right? The solution not only increases the effectiveness of the patch process, but it cuts the operational costs and reduces patch cycle times. Okay? It provides automated patch management to hundreds of thousands of endpoints for multiple operating systems and applications, regardless of location, connection type, or status. Right? Applies only the correct patches required to the endpoint. Right? Gives you greater visibility into patch compliance and flexibility, real-time monitoring and reporting. It provides real-time visibility and control from a single management console. So that single console that you saw the screenshots for, that's where everybody would work to manage their endpoint. So if you have a silo infrastructure where you have your server team that deals with just their Windows servers, and you have another team that deals with your Red Hat Linux, another team for your desktops, they all can have access to the console, and they can only see what they need to see. It can be very granular. You can do it by OS, you can do it by department, you can do it by region, you can do it however you want. All right. So proactively reduces the security risk by streamlining remediation cycles from weeks literally down to hours. All right. So who is this going to benefit for? Well, it benefits a multitude within your environment. All right. Your mobile workforce would be huge. All right, because they're going to be managed no matter where they are. Okay. For patching, you're going to be able to patch them. If a 0-day patch comes out, you could apply that, and you can know if it's successful. Your operations, we're talking about patch management specifically. IT operations would benefit from this immensely. Your IT security compliance, because they want to see if they're patched. All right. The product has the ability to do, we said, power management. So even your facilities team would be able to see a huge benefit with this product because of its ability to manage the power cycles on your endpoint. So if you have a classroom or a training class with physical boxes sitting there, BigFix can shut them down at 6 o'clock at night and power them back on at 8 in the morning. Okay, and then asset management for your life cycle. So it's one console, one agent, one server, and database. It's all compacted together. All right, that can manage up to 250,000 endpoints. So with that, some of the main values, and I'm going to go over this again and again. One agent, reduce help desk calls, right, because it's not affecting your performance on that endpoint. You're not having your end user saying, "Wow, all of a sudden it's slowed down on me. I can't do anything." One console, so that, reduces the need for cross training. You have somebody who's doing patching of your endpoints, uses the same console if they want to do software deployments, or same console if they want to do OS upgrades or software inventory. All right, very small footprint on the endpoints reduces, again, the performance issues. Product can do so much. It equates to over 5 different point solutions, from software deployment, OS deployment, virus protection, security and compliance, power management, patching that we talked about. All right. It is backed by IBM. IBM again purchased this in 2010. They're using it, and they've been enhancing it ever since. And just some of the agencies that have this, OPM has adopted it, over 1 million endpoints. Marriott, Penn State, Severn ourselves, we've deployed on-premise installations, dozens of them, and currently we're providing management services for upward of 1 million endpoints on BigFix right now. So some other use cases that we throw out there for return of investment, you can go through this list here, and it shows you the reduction in administrative costs and overhead. Western Federal Credit Union reported a 50% reduction in labor costs with automation and unified messaging, and so on and so forth. So with that, the last thing I want to bring to your attention here is, this is a focus on patch management. As you can see, the solution itself is much more wider than that. It can scale out not only within your infrastructure, like we discussed, but within your silos, within your departments, for operations, for security, for other compliance reporting. The solution can handle that. It is also, quite honestly, a key pillar in the security effort that your security CISO should be interested in. A last slide I'll throw you with is, if you look at the overall security solution through integration that Cas7 provides, we've been focusing on the endpoint domain, as you can see in the upper middle. All right, and with that, it's BigFix. Okay, but this BigFix then plays a much bigger role in the whole security of your whole environment, whether you're interested in the SIM tool down the road or dealing with other domains. Your endpoints are your most vulnerable, and that's where you need to make sure you protect it, which BigFix can do. So with that, I appreciate you taking the time to join the call. Again, my name is Chris Lumpkin. I'm a Senior Securities Architect. My contact information is here, and would welcome any kind of comments or questions going forward. So once again, thank you for your time, and have a great day.